So for part C, it's definitely turned out to be the trickiest of all of these problems. And to ever find a minimum or a maximum, we want our derivative, in this case it would be x prime, to equal 0, and we'd ultimately want it to be going from minus to plus. But on the rubric, the AP board is giving credit for, are you setting your derivative equal to 0? So our derivative was, in the x direction, t minus 1 times e to the t squared. We want this to be equal to 0. Well, this exponential will never be 0. But t minus 1 will be 0 at t equals 1. And you could have also graphed it since this was a calculator, okay, but it's faster in this case to just see, oh, okay. I need to check when t is 1. And then I should check my endpoints, but notice it's just t is greater than 0. So there's going to be no right endpoint. And that's going to be part of why we never get to the farthest right. So I'm going to think about how I do any maximum or minimum problem. I'm just going to make myself a table. I'm going to look at our endpoints and our critical points. So we've got time and x of t. We know our initial position at 0 is negative 2. And at 1, we will have our initial position of negative 2 plus the integral from 0 to this critical point 1 of my x prime t. And I'll find what that is. And notice, since I already had y1 as my x rate, my x prime, I can just do negative 2, my starting value, plus the integral from 0 to 1. And here is my position at the location I want. Now there's so many ways to think about this next part, but you have found now your farthest left. And it's at time 1. And there's no endpoint. All we can do is really think about the limit as t approaches infinity. Here's the graph of x prime of t. Here's our t equals 1. Because this derivative is always positive, you can think about this area as always being above the x-axis. So this will be positive position. So we are always going to be going to the right. And so there will be no farthest right place because we will go right forever. And now we just need to put that into a form that the AP board would like. So we can say at t equals 1, we're farthest left. At t is greater than 1, x prime of t is greater than 0, we're always traveling right. And so there will be no farthest right. One of the important things is that you say x prime is the thing that's so important. Now let's look and make sure we haven't missed anything. Find the coordinates of the point at which the particle is farthest right. We never did find the y value, so we should do that. Our y will be equal to our starting y value, which was 5, plus now we're going to do the integral from 0 to 1 of our y prime t. And that was saved in our calculator as y1. So we'll go ahead and do that. We went ahead and plugged that in the calculator. We'll hit enter. So now we have both the x position and the y position when we are farthest left. So now let's just scroll through and make sure we have everything. we set our derivative equal to 0, we found the value, we set up a table to kind of show the endpoints that we could find, and the fact that the other endpoint, there wasn't one because we went on forever. We made a little graph and explained that we went on forever, moving positively to the right, so there would be no farthest right, so we've covered everything.